Good day, everybody. I'm here to present paper 70 in the International Conference on Systems and Information Science. That is called Yaniwawa, an innovative tool for teaching using programmable models over augmented reality sandbox. My name is Luis Escobar. I'm going to present this paper in name of all the authors. At the beginning, I'm going to give you a brief resume of the contents of the paper that are going to be shown in this presentation. First, an introduction to share with you the motivation for this research, then the materials and methods that we use to develop our system, finally, results and discussion and conclusions. First, the introduction. Exploration is crucial when the development of innovative and creative is needed. High levels of exploration imply variance seeking rather than mean seeking learning processes. Learning is more effective when the tasks operate without autonomy with respect to goals and supervision. In this context, educational theorists as Kolb and Fry developed the experimental learning model. In this model of learning, individuals are stimulated to reflect on their actions and consequences in order to foster understanding and applying these skills in future actions. The model helps teachers design lessons experimental, interactive in order to develop critical and creative thinkers. The model consists of 4 stages: concrete experience, reflective observation, abstract conceptualization, and active experimentation. ELM is an integrated process, each stage being mutually supportive of and feeding into the next. It is possible to start the learning at any stage. The important thing is to follow the sequence as seen in this figure. The research and development of sandboxes augmented reality is not new. There is said that there are more than 150 sandboxes around the world, and there is other page where you can see the distribution. It is important that you know 3 aspects involved in the implementation of the system. The first one is the learning process, the second one is the structure, and the third one is software. The learning process is totally based in gamification of the theories, and the structure is proposed in this present research is a generic way uses 2 systems that interact with each other. The steel support was built to hold 2 devices. The first one is the basic air sandbox as shown in previous research. And the second one consists in a computer used to project the elevation chosen by the user through a maker connected to a Mackay car, as can be seen in this. The main system of this prototype is all this software development. Yaniwawa application was programmed in C# language. This game combines NUI and frontal projection to simulate a tactile screen. The required elements are a sort through projector and a Kinect. The screen area is a box filled with sand. To achieve the user interaction, the Kinect device was used. It was located next to the top projector. The top projector and the Kinect devices were located above the sandbox. Interactive interface were connected with the sandbox by means of a Mackay and alligator clips. Buttons were built in the model for each mountain. This card was configured to perform the interaction among the sandbox in the button and the application hosted on the laptop. The main interface includes a map of Ecuador that has been adapted to the model and presented 8 of the most important mountains learned in school. The interface of each mountain shows its image, a video of the local wildlife, in addition an audio describing the most important characteristics of it. The Yaniwawa architecture self-explained in this figure. To test our model, 2 game modes were developed. The first one has the aim to teach the Ecuadorian Andean system, and the second one Node used the Ecuadorian coastal profile to teach children about peninsulas, inlets, gulfs, and so other geographical forms. The markers on the system help the children to get information about specific points on the map. In our case, these were the most important mountains present in the Ecuador. The gamification process of this prototype was introduced with children in the fashion that first they were free to play with the sand and see how this model works, making mountains and other geographical forms. After a time where they familiarized with the prototype, they were asked to form the map that is presented of Ecuador, and once they have the map formed, they were asked to identify different mountains. At the beginning, it was a pretest to get information of how many mountains they already know. Once they pass this test, the children have a time to ask and play with the instructors to get more information. And at the end of the day, they were asked again to recognize the mountains, getting better results. For this study, we have a group of children between 11 and 13 years old. Here we have the distribution of the children, seeing that we have more an average of 12 years old children. We have these three phases clearly identified when we were interacting with them. The first phase is knowledge assessment before the experiment. So the children were asked how many mountains they know. They were asked to identify the mountains in the map and to play with the system. In the phase 2, they were asked to interact with the system, play with the sand, and ask the information directly to the system. And in the phase 3, we make the evaluation after a time to look if they have improved their knowledge. Here we can see the results after the first test and after the second test. In yellow, we have the results of the children when they were asked before the completion of the task. And in red, we have the completion after they were asked to identify the mountains again. We can see here that the mean values for each series are 3.3 correct answers in the pre-test and 5.8 correct answers in the post-test. It is clear that they have improvements. We can see that at the beginning there were some children that didn't know any of the mountains, and after the game they at least get 2 mountains correct. We have extreme cases where they get all the mountains correct, and others where we can see an improvement of almost double. Another mean to measure the potential of this prototype in this current research was evaluated through a short questionnaire made to the children that interact with this prototype. It has 7 items that evaluated ease of use, understand and learn. Also, a part of the questionnaire asked the children if they had fun and recommend this game to a friend. All the questionnaire were scored from 1 to 5, being 5 very satisfied. The first, third, fifth and sixth questions that are shown in this presentation show that more than the 77% of the participants give their greatest score, as can be seen here. Being this questionnaire related to how fun the game was, if the user want to play again, and how easy it was to use it and learn with it. Here we have the questions. The question 1 was asked Was this game fun? And almost all the children were very satisfied. And none of them were insatisfied or neutral. All of them enjoyed this game. In the question 3, we have, do you want to play a game? So everybody except 3 children were very satisfied and wanted to play a game. The question 5 asked if it is easy to use the game, and almost all the children were very satisfied. Only 2 don't get it very quickly, but with the explanation of the instructors, they understand later how to play. And in the question 6, that is easy to learn with this game, almost all the children were very satisfied. The last question asked in a global fashion if they scored the game from 0 to 5. And only 4 children scored it with neutral, 4 children scored with satisfied, and 32 children of the group declared that this game was very satisfactory. We can see here that more than 80% of the children said that this game is very satisfactory. At the end, we have a section for discussion and conclusion of our prototype. The results obtained in the test about mountains and snowy mountains reveals important information about how the system helps children remember twice the names of the mountains taught. Moreover, almost all the children believed that the game was fun, easy to use, and learn with it, as can be seen in the figure shown before. The lower scores in question 2 and 4 were mainly due to the scarce experience of the staff in charge of giving the instructions to deal with children. And the final question showed that the children found easy to play with it. Unlike other words presented before, an extra device helped to specify information about landscape, and it helped children to get more interested in the game, because it allows to get a deeper interaction with the game, a more natural one. The research showed that the tools as Maki is in conjunction with other technologies and methods let children to have a meaningful experience in a short period of time, increasing the knowledge, enriching and complementing the traditional method of teaching. As a future work, it is intended to use a printed 3D model to show how different physical phenomena may affect a landscape and what kind of consequences. Thank you very much. If you have any questions, you can write directly to the authors. We will be happy to answer